Lasst uns mal mit den Sponsoren anfangen. Vielen Dank, dass Sie sponsoriert haben. Jetzt werden wir über Quarkus sprechen. Mein Name ist Peter Palaga. Hallo noch einmal, weil ich habe vorhin schon einen Talk gehalten. Damit es für euch nicht so langweilig ist, ich habe mindestens mein T-Shirt gewechselt von Camel auf Red Hat. Ein Quarkus-T-Shirt besitze ich leider noch nicht. Ich komme aus der Slowakei, wohne in Tschechien, spreche Deutsch, da ich 8 Jahre lang in Deutschland gewohnt, studiert und gearbeitet habe. Aber den Rest des Talks werde ich lieber auf Englisch vortragen, weil es so sicherer für mich ist. So, I am an engineer assigned to a product called Red Hat Fuse. Red Hat Fuse is an integration platform which is basically the same code base like Apache Camel. So I'm supposed to work actually on both. For the recent couple of months, I'm spending the most of my time by porting Apache Camel components to Quarkus and creating Quarkus extensions. And that's actually my qualification for this talk. I'm not from the Quarkus core team, but I'm using Quarkus daily. In the past, I was paid for fixing bugs in Wildfly and JBoss EAP, as well as in several other Red Hat middleware products. In my free time, I like hacking in build tools. I'm the author of SourceSteps, which is a tool that allows you to define your dependencies in terms of Git commits and Git repositories. And the tool compiles the dependencies for you on demand when they are needed. I have also co-written a parser for editor config in Java, and I have written a Maven plugin for enforcing the editor config rules. A very simplified summary of this talk could be that it consists of an 8 milliseconds demo and 50 minutes of theory, what happened during those 8 milliseconds. But I hope I'm not going to be boring, and I hope in the end you have a fairly good idea what is Quarkus, what is it good for, and how it works internally. So let's start with the short demo. I have compiled it before this session because it takes about a minute, and I didn't want to bore you with watching Maven output. But the result of the compilation is like this. There's a file that has no extension, and it has no extension because it's a Linux executable. It's just 19 megabytes small, and I can run it. Have you seen how fast this was? And once again, this fast, okay? It shows 4 milliseconds to start. And let's check if it works. Yes, it happens to work. Let's check how much memory is it spending. And it spends about 17 megabytes of RAM. Is this nice? Yes, it is. For an application, for a web application written in Java, this is very, very nice. So let's have a look how this is possible. So, what is Quarkus? Quarkus is a toolkit in the first place and a little bit of framework for writing Java, Kotlin, and Scala applications. When I say that it's a toolkit, this is why, because The way you are supposed, you as an application developer, the way you are supposed to interact with Quarkus is through having it as a part of your Maven or Gradle setup. There's Maven or Gradle plugin that does the magic for you. The input for the plugin is compiled Java code, either in form of Java classes or jar files. And the output is something we call optimized jar. This jar can be run on a stock JVM, such as OpenJDK. And alternatively, you can pass the jar to GraalVM, and GraalVM produces a native executable like the one we have seen in the demo. It's very important to know that there are these two modes. We will speak of them all the time. This mode is fast to compile, but slower to boot and spends a bit more RAM. This one is longer to compile, but faster to boot and spends less RAM, okay? So while you are developing, you are mostly working in the JVM mode, and when you are satisfied with the result, you go native. Good. So when I said that it's a toolkit in the first place, you may ask, how the hell am I supposed to write my application? And the answer is that Quarkus is embracing existing standards, like the good old ones from Java EE, like servlet, JAX-RS for REST, JPA, JDBC for persistence, CDI, transactions, and so on. But it also supports the newer microprofile profiles like health, fault tolerance, metrics, reactive messaging, OpenAPI, REST client, and so on. And there's also some support for Spring, which is a de facto standard. And the support works through a compatibility layer. And there are compatibility layers for Spring dependency injection, for Spring Web, and Spring Data. Compatibility layer means that the annotations coming from the Spring Java packages are mapped to the ones available in the microprofile or Java EE implementations of the respective specifications, okay? So it's not only standards, it's also well-known, well-established libraries and frameworks which are by no means standards, such as Apache Camel, which I work on, or Vertex for reactive, native or low-level networking, InfiniSpan client for cache, or Caffeine for local cache, Keycloak for role-based authorization, Kubernetes, Lambda, Azure Functions, and so on. And there's also a nice support for many, many databases. There's extensions for JDBC drivers of databases you see here on the left. And there's also support for Flyway, for database schema migrations, for DynamoDB, MongoDB, and Neo4j. Quarkus unifies imperative and reactive model under the same roof. You can use both inside the same application. And the bottom line is that newly, since Quarkus 1.025 is fully based on Vertex, and actually also Undertow 3 that is used there is just a thin layer on top of Vertex. Quarkus was designed to offer lots of developer joy. And the first thing to start is code Quarkus.io, which is there to create starter projects for you. So let's take the simplest one. Let's unpack it here. And let's open it with Visual Studio Code. So there's a POM file that imports Quarkus BOM, that manages the versions of the dependencies that are there. There's only one compile dependency for Quarkus REST easy because we have chosen just the REST entry there in the UI. And there are two dependencies for testing. Let's look at the Java code. This is the endpoint, just a single hello. When you look at this is a stock JAX-RS endpoint, and there's nothing Quarkus specific here. If you know JAX-RS, you know how to code for Quarkus. And this is the same with all those other specifications. Good. What's there next? There's dev mode for live reload. Let's open a terminal and let's start. Let's clean compile and execute the Maven, the Quarkus plugin module called dev, which will keep. Oh, something's wrong. The wrong is that I haven't killed this one. No. So let's start this one again. It compiles and starts the stack on the background, and it is watching for the changes in my workspace. So when I change this to Gruzy Basel, hit save, nothing changes, but here when I hit refresh, it has recompiled and returns Gruzy Basel. Let's try more. Let's change the greeting based on some property. My greeting default value be high. So this one is going to come from here, string greeting, and let's concat save, refresh, and it's there, the default value. But I don't want the default value, I want to configure it. So I called it my greeting, I hope. And I will call it Guten Tag. Hit save, hit refresh, and Guten Tag is there. Oh, it's this one, which is funny. Because this shouldn't be there. Okay. We could add here a query parameter. Query this one, name, string. And is there an error? Query files add. But let's try with the error, what happens. Because I want to show you what happens if there is an error. And I get the stack trace here returned, which is also nice. I basically know that I have a syntax problem. So let's just add add, hit save, refresh, and it should be still not okay. What's wrong? Import, save, it's there, and I should supply name Joe, for example. Works. So you get the idea how live reload works. Let's get back to the presentation. There's support for Java, Kotlin, and newly also Scala. I don't know how good Scala support is. The support for Maven and Gradle, and their support for JUnit 5 and 4, where 4 is deprecated now. The project generator actually produced a simple test for us, and if I run the test, it will fail because we have changed the greeting, and this is the test. Is hello, and in reality it is Guten Tag null. So if I put Guten Tag null here, it should pass. So it's not passing. I have pasted it somewhere else. I'm sorry. This is the test for the JVM mode, and there's a separate class for the native mode. It's separate because it needs a separate runner. So the native mode is run with the substrate test runner, and this one is run with Quarkus test. Good, now the test has passed. And it also isolates you from the GraalVM CLI and API. You actually don't need to care for GraalVM at all. You even don't need to download it because GraalVM, because Quarkus offers the option to build it inside Docker, and it downloads the right Docker image for you. So now when I start it, it will take about a minute to do the native compilation. This is the command it runs to produce the native image, but you basically don't need to care. All you need to do is to have the Quarkus plugin inside your POM. This is the build for JVM, and the optional native profile with the native image goal is there separate so that you can choose which one you want. If you want to wait for longer, you can choose the native. So the native is not finished. I'm not going to wait. It's not interesting. You have already seen the result. Quarkus was built with container first on mind. So to have small containers, it's always practical to be able to push them quickly. They are booting fast and so on. Fast boot time is super important, and you have seen how fast it can be. And the low memory footprint is super important as well. But let's have a look at the numbers. First, the memory. As a Java developer, you surely know about heap size and permanent space and things like that, but that's not what matters in containers. In containers, what matters is the overall, the complete amount of RAM your Java process is using. And that's what the term RSS contains. That's exactly what we want to know. PS, minus R, and so on is one way to show it. I have used it at the beginning. So this is the rough comparison for a simple application that contains just a single REST endpoint like the one I have shown you in the demo. So with Quarkus Graal VM, we are somewhere under 20 MB. When we run in the JVM mode, we are around 74, and compared to some traditional cloud-native stack, you are roughly 10 times more than the native. If you add JPA using Hibernate to the mix, the numbers are a bit different, but the general idea is like this. Let's look at the boot time. So what the modern frameworks often do, they use lazy initialization. And they report on the console that they started even before all the classes needed to serve your requests are loaded, okay? So what matters is the time to first request. And that's something that should tell us the real measure, how much it takes until our request is served. How this can be measured is very easy. You add a simple print line with the current time in milliseconds before the real business logic is executed. Then you start a request producer, a curl in a while loop, and this is every 10 nanoseconds or something like that. And then before starting your application, you echo the console time, which is this time, and this is the time our system out is outputting, and when you subtract the two, you get time to first request, which is quite easy to do for any framework. And this is how we measured the numbers. So with Quarkus on Graal VM, we are under 20 milliseconds. On this laptop, it has shown 4 milliseconds at the beginning in the console, but real time was 8 milliseconds. So with in the JVM mode, we are under a second, again for the simple REST application, and with traditional cloud-native stack, we are at a couple of seconds, which is how much faster? 100 times. Nice. So again, the numbers are slightly different when we add the JPA to the mix, but you get the idea. Now, how it works? Let's look at the magic that Quarkus is doing behind the scenes inside that Quarkus plugin. Within or inside the traditional application servers, there are literally hundreds of classes that are run only during the boot. And then later, they still occupy the space. They are still loaded. And it also has costed some time to run that code. Think of XML parsers, annotation lookups, building some management model for deploying jar vars, and so on. So the main trick of Quarkus is to do as much as possible of these things at build time. And all those tasks that are done at the build time are recorded directly to bytecode. Let's explain this at an example of CDI. CDI is dependency injection. So it means that you want to inject beans here and there, and typically at boot time in the container, all injection points need to be found in your classes, which can be quite a long process if you have many classes. All possible bean producers need to be identified, and those need to be matched against each other, which also may be a complicated process. And because inside Quarkus this can happen, and it's indeed happening at the build time, that wiring, those decisions, which bean fits into which injection points, can be hard-coded as directly into bytecode that is run at the boot time then. And this is how it could look like in a pseudocode. Real code is only this. These are the user beans. So let's say the user is having a pricing bean and a catalog bean, and the catalog bean depends or injects the pricing, and it has some post-construct method. So at build time, the CDI extension of Quarkus is able to identify all of these. It knows that this is the only candidate for this injection point, and it's able to generate as a bytecode, this is just a Java pseudocode, something like this, some metadata, right? So to create a catalog bean means executing exactly these steps, and those can be recorded directly as a bytecode. And then, in some static initializer of some class, which happens to be called application, we would have something like this, a map for the metadata that we have produced here, and this is the wiring that happens there, and here for some beans we can directly instantiate them in the static initializer. As an example, what Quarkus extensions are doing. Good. So the recorded bytecode can be written either into a static initializer or into a main method. And this one is preferred, and this one needs to be used if you cannot use static initializer, which is in cases when you need to access resources which are available only during the runtime. And the reason for this distinction is GraalVM, and we will explain later why it is the case. By the way, what's the time? Okay. So there are distinct extensions taking care for various aspects of the applications. And the extensions are ways how to extend Quarkus, and how also third parties could add support for some library or framework. Extensions are basically units of Quarkus distribution. I have shown you in the POM file, those are basically Maven artifacts that you are supposed to use as a Maven dependency. They configure, boot, and integrate a framework or a library into a Quarkus application, and they do the magic like I shown you with the CDI. So new extensions are very welcome. If you decide, or when you find that your favorite framework is not supported, you should definitely follow the guide that is there on Quarkus.io site, and it's quite detailed and helpful. You can also post your question on their chat, or post a message to their mailing list. Quarkus extensions can be developed by third parties independently of Red Hat. Actually, what we do at Camel Quarkus is exactly that. We are only consuming their artifacts, and our dependency on them is very, very loose. So, and soon they prepare an integration for third parties to appear on codequarkus.io too, where those starter applications can be generated. Good. That was the Quarkus tooling that produces the optimized jar. Now you hopefully have an idea what happens inside that tooling and what that optimized jar contains, and why also already this optimized jar is quite fast to boot on JVM and quite spends a bit less memory than compared to traditional containers. Now let's look at GraalVM. GraalVM first may mean two distinct things. Either it's Graal compiler, which can be used either as an ahead-of-time compiler or a just-in-time compiler inside traditional JVM, or it's a name for an umbrella of several other projects where the Graal compiler is included too. And in this presentation, only the Graal compiler and the substrate virtual machine are going to be included under the term GraalVM. So what it means to compile ahead of time using Graal compiler. There are three kinds of input. First, the classes you have coded inside your application. Second, the class is coming from the standard JDK. And third, the class is coming from the substrate VM. I'm not going to explain in deep what substrate VM is doing, but roughly it replaces some things from the standard JDK to make the native compilation possible. And the result is a native executable. It's not statically linked, sorry. So what's going on there? There's a lot of static analysis happening, and the result is an elimination of code that is not used. Whole classes, fields, methods, and if branches can disappear from the code if the Graal compiler can think that the code is never going to be executed. How can it know? The answer is it's making this closed world assumption. It means that at build time, every single piece of code needs to be known that is going to be available at build time. This is a very strong assumption, limitation, that has lots of unpleasant consequences, but it also has lots of benefits. And that's exactly it. Graal compiler can do a lot of optimizations based on that assumption. So when you are using plain Graal, the Graal compiler, you use the native image command with an input of your jar, and the result is the native executable. And now let's speak about the limitations of GraalVM. First, there's no just-in-time compilation in the native executable. There's garbage collection, but no JIT. And what it means is that the native executables are going to serve requests slowly compared to traditional JVMs. Because JVM, after warm-up, can perform the just-in-time compilation based on runtime data. And this can eliminate even more code than the Graal compiler is able to at build time. So you should measure your use case and see if it matters to you. But in a typical case, this is what happens. For running a traditional Java application instance, you need maybe 10-ish more RAM. And if you can run 10 smaller Quarkus containers with the same RAM for the same money, actually, it doesn't matter much that each of those smaller Quarkus containers is serving the requests 7% slower. You get higher efficiency with Quarkus like this, although the latency is higher. But think for your use case if this matters to you, okay? Now this dynamic class loading is not supported at all, and the consequence is that you are not going to be able to implement a Java EE container on GraalVM, because deploying web applications through WARs means exactly dynamic class loading. If it's not there, it's not possible. JVMTI and JMX are not there because there's no bytecode, actually, it's native code. And all those are typically manipulating bytecode, and if the bytecode is not there, then there are no agents. So, and this means no profilers and no JRebel byteman and the like. The same holds for Java debugger. Because there's no bytecode, there's also no Java debugger in the native mode. This is not the case in the JVM mode, okay? In JVM mode, everything works as usual. You have agents, debugger, and so on. When you are in the native mode, the only thing you can do is to use a native debugger, like GDB. And if you are rich enough and buy a license for GraalVM Enterprise, you will get dwarf debug symbols into your binary, which allows you to step through the source Java file. So there's more things unsupported, such as security manager, but it doesn't matter much because you are probably not going to run untrusted code. There's no finalize, which I hope doesn't matter much for you because it's deprecated and it doesn't work, actually. Invoke dynamic and method handles don't work, which is actually interesting because Java 8 lambdas are implemented using invoke dynamic. And you may ask yourself, how does it work? And the answer is that there's a replacement in the substrate VM for this, and the lambdas are implemented as a stock methods on GraalVM. Good. Reflection is limited. You need to register classes for reflection upfront, and GraalVM or the Graal compiler is going to generate code that is accessing the things you need. And Quarkus offers a special annotation for this purpose. So if you need reflection somewhere where Quarkus is not able to figure out itself, which the extensions are supposed to, for like Hibernate entities, the Hibernate extension is adding the register for reflection automatically for you there. But in some cases, you need to do this yourself. Good. There's more limited or things that need to be registered up front, such as dynamic proxies, resources, JNI, and so on. And now let's speak about the static initialization, which is very special. And you may remember the distinction where the generated bytecode is put by Quarkus tooling, either static initializer or the main method. So why is static initialization so special with GraalVM? This is what happens. The build-time OpenJDK instance that the Graal compiler starts resolves all classes and runs all static initializers that are not marked specially to be run at runtime. And then it takes a snapshot of the whole heap of the VM, and it simply stores it into the executable. And the result is that when the executable starts, that image is just copied into the memory, and no class loading, no class resolution needs to happen. And that's why the native executables are so blazing fast. No class resolution. It's just copied into the memory, and it's there. That's why. But of course, it has downsides. If this is supposed to happen at build time, if your static initializer happens to access files and opening sockets and things like that, it won't work, because the files that are there at build time are typically not what you want, right? So you either need to put the code into the main method, or you need to mark the class or the initializer with a special something, so that the GraalVM knows that this one needs to happen at runtime. So, and this is also kind of limitation of GraalVM. When you work directly with it, you need to know lots of things about it. This is typically what you would run on command line to compile a simple Java application. It's tens of command line parameters that you need to know about, and some of them are files that may have tens or hundreds of entries in them. And this is what Quarkus very, very, very good shields you from. You don't need to know this at all. All that knowledge is encoded inside the extensions that support your library or framework. So what's the time? We started at 20 past, so we have like 8 minutes. I have used the Docker way to compile to native image at the beginning, because I think it's easier, because I don't need to care for the right GraalVM version. But if you want, and actually, if you want to produce native executables for Mac, I actually don't know if Windows is supported already. So probably working with Docker is the only good option for you to work on Windows. But anyway, the option to work with GraalVM directly exists, and you need to download the right version that is compatible with the given Quarkus version. And you need to export the GraalVM home environment variable, and then it works the same, basically, like I have shown you. Good. The way to discover extensions, you can either go to code quarkus.io, or you can use this mojo of the Quarkus plugin, and it lists all the available extensions there. There's another mojo that adds the extension, the dependency for the given extension into your home. And one of those extensions is Panache. Panache is a simplified Hibernate, so to say. If you don't want to produce all the boilerplate with getters and setters and all those typical annotations, you can extend Panache entity on Alice. Everything is added for you there. If you do it, this is how you would be supposed to work. You don't need to use entity manager anymore. You can call Persist directly on the person once you have created it, and the same for delete. You have static methods generated for listing and filtering, and by various parameters. There's count, there's delete all, and delete by fields. There's also support for paging sorting, simplified query language, auto-generated Spring Data-like DAOs and repositories. That was basically it. As you hopefully have understood, programming for Quarkus is good old Java with good old standards and libs. You don't need to learn either anything or just small little things. And you get the efficiency level of the Go language, and your team or your company doesn't need to care for migrating away from Java anymore, actually, when you have the problems in the cloud, in containers. That's it. These are the links. The Quarkus team is monitoring Stack Overflow very well, so if you have questions, that's probably the best way to go. Post a question on Stack Overflow. There are quick starts. There's the starter page, which I actually should have listed here. And that's it. Thank you very much. Questions?
You talked about the CDI integration, let's say. Is it full supported?
That's a good question. The question is if CDI is full supported. So there's a special implementation there that is called Arc. And Arc is not 100% a full implementation of CDI 2.1, I think. There are definitely things that are not implemented yet that eventually are going to get implemented. And all those are documented on the Quarkus site. You have to follow the guide for CDI. And some of them are not implemented for technical reasons because it's probably not possible. That's the answer. More questions? No?
On that one slide you showed the latency of those applications produced with the native image are higher than with traditional Java.
Yes?
How would that happen? I didn't quite...
Because the question is, how did the difference in latency between native executable and running on JVM happen? And it happens because there's no just-in-time compilation inside the native executable. There's garbage collector, but no JIT. That's the answer. Another question?
Yeah, as no training support, is there, for example, Jaeger support?
Yes. Is there Jaeger support? And the answer is yes.
I also heard that with Hibernate, for example, some features that are not implemented for technical reasons or even with REST. So is there somewhere an overview or a list of what the difference is?
So the question is, for Hibernate, he has heard something is not implemented too for technical reasons, and whether this is documented as it is on quarkus.io. Here the guides, and there must be a persistence or Hibernate guide somewhere. This one, and I'd suppose the things to be documented there.
But those are just those Java EE standards are all re-implemented basically from scratch.
Not really. Because those are basically the same people working on those extensions who developed the core Hibernate. So this is basically the next version of Hibernate. Everything which is possible goes to the upstream, and what cannot stays in the extension. But they are really motivated to push everything into Hibernate itself. So the next stock version of Hibernate is going to work basically the same like on Quarkus.
How is it with REST API? What is the implementation of the
REST easy.
REST interface?
More questions somewhere?
This extension discussion, does it mean that every Java library that one wants to use needs to be being extended by the provider or by himself, basically? Or generally, can you use any Java library?
If I understand the question, I'll repeat it. If I can use any Java library and compile it to native, that's the question?
Yeah, well, to use it with this native compiler.
So,
Adapt the existing Java library.
okay, so if a Quarkus extension exists, you are fine and you are basically supported because somebody cared. If an extension doesn't exist, maybe you are lucky and it would work anyway, because maybe the framework and library doesn't use any reflection, maybe, and things. Sometimes, or most of times, you need some adjustments that happen inside the extensions, but sometimes you are lucky. With Camel Quarkus, we definitely have extensions that do nothing. They just repackage a bare Camel library without any adjustments. So it definitely happens sometimes. More questions? No questions? Thank you very much. You can come to me for about 10 minutes because then I'm leaving to the airport. And, which I didn't say, I'm going to post the slides on my Twitter account here. Here you can still see all the slides from my previous talk. But I'll post these ones from today later, I don't know, today or tomorrow. Thank you very much.